Charge it. Good evening to the students. I welcome you all in this presentation of Mechanical Engineering. Myself Geetanjali Raghav, Assistant Professor in the Department of Mechanical Engineering. Before proceeding towards the details of the branch, let's have a brief overview of what we'll be discussing in this whole presentation. First, we'll be discussing about the introduction part, what actually mechanical engineering is. Then we'll be discussing about what the students are going to study in the upcoming 4 years duration of the mechanical engineering, and to uh, to incorporate the theory part into the practical exposure, what are the lab facilities we have in our campus, as well as the career opportunities. After completing your BTech, what are the career opportunities you have in your way to complete as your career as a mechanical engineer? So let's start with the topic, what actually mechanical engineering is. It is an engineering that applies the principles of physics, mathematics, material science for the design, analysis, maintenance, and manufacturing of mechanical systems. Basically, the mechanical engineering it is based on a term mechanism for converting input to output when we have certain mechanisms that comes under the category of mechanical engineering. That is, wherever you have the term mechanism, wherever you have the term motion and machines involving some type of mechanism, there is mechanical engineering. It is one of the oldest as well as the broadest discipline of engineering. Starting from your wristwatch gear system to the thermal power system, everywhere mechanical engineering is there. If we talk about the IC engines, it is there. If we talk about the CD player system, it is there. If we talk about the aircraft systems, it is there. If you talk about the minute heart valves inside your heart, which is replaced, that is again an example of mechanical engineering. So it is the broadest field which will be there in each and every part of the system. Now, mechanical engineering, you'll find it in robotics, in automotive sector, in petroleum and gas sector, thermal and fluid system, machine design, aviation industry, mining, rigging, refrigerations, your domestic refrigerators at your home, your cooling systems at your home, everywhere there is. Now, being a student, how or why should I choose the mechanical engineering? Here is the reason. If you're interested to make engines, if you're interested in machines, if you're interested in robots, you can opt for this branch. If you want to generate energy and power and you're interested in the sector, you can opt for mechanical engineering. If you want to explore and understand the applicable science, that means till 12th standard we have studied only basic science. So if we want to explore that science, we can go for mechanical engineering. And nowadays there is a boom in the sector of materials. Different materials with high strength, high toughness are now being emerged. So if you want to create new materials, you can opt for this branch. Now let's understand what a mechanical engineer do. Basically, a mechanical engineer do the research, development, design, manufacturing, and test tools of the engines, machines, and other mechanical devices. They work on power producing devices like generators, IC engines, steam turbines, gas turbines, thermal power plants, as well as they work on power using machines like refrigeration, air conditioning equipments, your elevators, which you find in every mall, escalators, industrial production equipments, and as well as robots, which are there as a helping human hand in every industry nowadays. Mechanical engineers also design tools that other engineers need for their work. Mechanical engineers may work in production, operation, in manufacturing, in agricultural sectors, that means equipments used for agricultural purpose, maintenance, or even for the technical sales purpose too. They are good administrators as well as a good managers. Now, let's talk about in the 4 years duration how students proceed from a basic science to a perfect mechanical engineering sector. So, in first year and second year, basically we go for the basic science subjects that involves chemistry, maths, physics, environmental studies, applied numerical techniques. That means without going through the detailed concepts of chemistry, maths, and physics, we cannot go for the detailed engineering part, detailed mechanical engineering part. Mathematics is required for forming the equations in mechanical engineering, mechanical systems. Physics is required for studying the heat transfer, force analysis for mechanical engineering systems, as well as chemistry is required, for example, biogas plant. We do pyrolysis there. So chemical equations are required for performing the pyrolysis operation. Apart from this, we have design thinking, English communication skills, uh, and their respective labs too. When we talk about as in the first year, when we step into the general engineering part, that means a student who is proceeding towards mechanical engineering, he should understand or he should be aware about the basic engineering of all the branches. That means the basic concepts of all the branches. That's why we have included our basic electrical and electronics part, we have included our computer programming part, workshop technology part, electrical and electronics part, as well as we have engineering graphics too. It is one of the foremost and the basic founded subject required in the mechanical engineering department. Graphics is something like if you want to design a component or if you want to manufacture a component, engineering graphics is required to design it. You want to convert, initially you want to design that component, and that is we do with the help of graphics and drawing. Moving towards the second year, we have the core subjects, that means the basic subjects, which forms the foundation of mechanical engineering. In this, we have engineering thermodynamics, in which we will study all the laws related to heat, thermodynamics. Then we have fluid mechanics, in which we study the behavior of flow. Machine and assembly drawing, in which we study, for example, you have a car. In car, there are different components. Now, when you want to assemble them, you can assemble them with the help of machine and assembly drawing. We have manufacturing technology, material science. In material science, we study the behavior of different materials. Then we have mechanical measurement and metrology. In this, we study the different mechanical instruments used in different industries. For example, vernier caliper and so on. Then we have mechanics of materials, theory of machines, thermal engineering, and their respective labs too. Moving toward the third year, we have turbo machinery. Turbo machinery is related to the rotating part of the system. For example, turbines, generators. Then we have design of machine elements, heat transfer. Heat transfer is essential in IC engines, in aircraft system, in almost all the industries which are involving chemical energy and heat energy as their main mode of heat transfer. Then we have IC engines, industrial engineering. Industrial engineering is being incorporated in each and every industry. As being working in an industry, you should be aware about all the industrial engineering aspects like Six Sigma, quality control systems, total quality management, and so on. Then we have operation research. Operation research dealt with the optimum utilization of minimum resources. That means maximum output out of minimum input. And then we have their respective labs as well as project. In final year, we have CAD/CAM, computer-aided design, as well as computer-aided manufacturing and its corresponding lab. Apart from this, all these subjects, we have certain specialized domain-oriented subjects in each semester. Like in semester 6, we have energy management, mechanical vibration, and quality reliability and safety subjects. Out of the three, we can opt for any one. Then in so on, in the seventh semester, we have refrigeration and air conditioning. This subject will be explaining about the basic concepts as well as the working system of all the domestic as well as commercial refrigerators and as well as the air conditioning systems. Then we have advanced manufacturing processes. Then we have finite element analysis, solar thermal technology, production and operation management, advanced machine design. In the semester 8, we have power plant engineering, in which we'll be explaining about the whole working procedure of a certain power plant. Example, solar thermal power plant, steam power plant. Then we have automobile engineering, computational fluid dynamics, modeling and simulation. Modeling and simulation is you want to model a certain system and you are testing it by providing the same condition that are there prevailing in the actual environmental conditions. Then we have PDD, product design and development, and then the last one is tribology. Tribology is related to the lubrication system. We have already studied all the subjects, that means whatever we are going to study in our 4-year tenure. Now let's look that how these subjects will help you in the practical environment or in the practical industry. Let's take an example of an aircraft industry. Suppose I am interested to design an aircraft. So initially the main point of focus will be its design. Then the design is only possible if you are aware about the engineering graphics or engineering drawing. Design is only possible if you are aware about the stresses, the forces which an aircraft will be bearing while traveling through the environmental condition. For that, you should be aware about the engineering mechanics part. You should be aware about the design of machine elements part. So here, the design part is over. Now, you are providing chemical energy as an input to the aircraft, and for its working, it is generating thrust to move in the forward direction. That means we are talking about engines now. For designing engines, we need to have a thorough knowledge of heat transfer, for thermodynamics, and related subjects. So after completing the heat engine part, now the leftover part is the material. What material we should choose to design an aircraft? The material that should withstand that certain toughness, so roughness and stresses, and which are there in the actual environment. So for that we should be aware about the material structure, we should be aware about the material science. So we should have a thorough knowledge of material science, manufacturing technologies, and so on. So therefore, after studying all these subjects, you will be comfortable with the analysis part of a particular mechanical system as well as the design, development, and testing part of that particular mechanical system. Now, we are we are done with the theory part. Now, to incorporate the theory part, practical exposure is the must. Without practical exposure, your theory is not completed. So in order to provide the practical exposure, we have almost more than 18 plus labs in our campus, and out of which we have here machine shop and measurement lab, where we have CNC machines, we have lathe, and so on. Then we have foundry shop, we have blacksmithy section in which the students will gain the basic knowledge about the smithy procedure. We have a CAM laboratory where computer aided manufacturing processes will be delivered to the students, how these processes are happening. Then we have IC engine lab in which emission testing is done. We have computer controlled machining lab. We have material testing lab in which the behavior of particular material is being tested. Mechanical properties, other properties are being tested here. Then we have fluid mechanics and machinery lab where you will gain all the knowledge related to the fluid flow behavior. That means how fluid flow, its behavior will be analyzed in this fluid mechanics lab. As well as we have certain machinery part also which is related to the turbines where we'll be testing, we have a test setup for different turbines here. We have Bosch Center of Excellence Mechatronics Lab here, where we have certain pneumatics, hydraulic systems, and different car manufacturing systems. Now, after completing all the practical and theory part, let's discuss about after completing the BTech degree, what are the career opportunities. So, as we have already discussed, where there is a machine, there is opportunity for mechanical engineers. You can find your career as an in aerospace industry and in research, design, manufacturing, or maintenance department. As well as you can find your career in automotive industry in design, manufacturing, distribution, even marketing department and design department. In chemical industry, you can build new power plants, develop new process technologies. In construction industry, civil engineers construct the buildings, as well as mechanical engineers provide the heating and ventilation operations to the building. In defense industries, mechanical engineers provide the equipments, support and services for the armed forces. For example, night vision devices for the army tanks. In electronic industry, the mechanical engineer design and manufacture components and complete equipments for the sector from automotive to medicine and military. In the area of fast moving and consumer good industry, all the FMCGs and all the small scale products industries involve the mechanical engineering part. For example, all the FMCGs are related to almost Hindustan Unilever Limited, and this firm is the largest recruiter of the mechanical engineering. In marine industry, you can find your career. In materials and metal industry, you can find your career. In pharmaceutical industry, you can manufacture and develop drug design systems. In rail industry, you can work as an power engineer, you can work as in construction engineer, design engineer. And if you want to make good engineers, mechanical engineers, you can join your career as a faculty or you can join your academia. These are some of the application areas of mechanical engineering: automotive sector, industrial manufacturing sector, locomotive sector. In construction, power sector, semiconductor and electronic sector. Solar engineering is nowadays utilizing the semiconductor and electronics part and as well as nanotechnology part to improve the efficiency of harnessing the solar energy, which is a part of mechanical engineering. These are some of the new frontiers, that means the latest technology in the field of mechanical engineering. Nanotechnology, when you are changing the structure of a material at nano level, that comes under the technology of nanotechnology. Robotics is a very booming field of mechanical engineering nowadays. We have biomechanics, in which you study the human behavior by utilizing some machines, by using some machines, as well as the composite materials. Composite materials deals with increasing the hardness, increasing the toughness of certain materials by making its composite with different materials. Now, what role as a mechanical engineer you find in a particular industry? You can work as an automotive engineer, cryogenics engineer. Cryogenics is a word which is there with a very low temperature applications, refrigeration systems, air conditioning systems. You can work as a design engineer, mechanical engineer, nuclear engineer, power plant engineer, tool engineer, as well as the tribologist. If you want to pursue your career further on for higher education, these are the fields in which you can perform or you can go for your specialization: mechatronics, nanotechnology, finite element analysis, computational fluid dynamics, thermodynamics or thermosciences, design and drafting, mechanics, mechatronics and robotics. So, after completing the mechanical engineering, as a mechanical engineer, you can go to any industry. You can go to government sector, PSUs. You can go to the R&D department, research and development department of any industry. You can go in military sector. You can go for technical sales and marketing sector. You can go to the education sector. You can work as a consultant. You can become an independent entrepreneur, or you can go for social services too. That means, on an average, mechanical engineering includes each and every part from our day-to-day life to our critical systems. So, if you are interested in machineries, functions, robotics, material science, micro devices, weapons design, aircraft, renewable energy systems like solar, thermal, wind, and their manufacturing, then mechanical engineering is the best choice to prove your ability and interest and find the career which you wish to. So I would like to welcome you to join the UPES. If there is any query, I will welcome this. If there is any query or any question from your side, thank you so much.